Hey guys, welcome back to our next video, and now here we are going to talk about Windows passwords, how Windows manage password, where does it save it, how does it work, and of course the overall mechanisms of comparing passwords, because as I said many times in the previous videos, before you learn something on the higher level, we need to know how it works on the bottom fundamental level. So we're going to cover the process of when you log into a Windows machine, you see that the login screen with passwords, or even with the UAC whenever you try to install or remove something that's important or maybe important, you've been prompted out with some kind of prompt that asks for passwords, and if you do not basically enter a password upon registration or installing Windows, you are just asked to click yes or no that you are sure. But on the enterprise basis, any Windows machine and server has so-called admin password, and whenever you try to do something that requires admin access, you've been prompted with that UAC that makes sure you are the admin so you can do the action you want. So let's start with what's the password management. I want to just explain from the very fundamental level how the password management is done in basically any system out there. Now here is some examples, some C code that do something like a login form. So basically this is really the lowest level of the C code of working. So anything here you can count as the bottom of anything, because here we did not implement any algorithm at all, we did not do nothing, we are just including libraries. You see the standard library for input and output. We are including the string library since we need to compare. So basically the password is just a string, is not only numbers, because one password can contain symbols, it can contain numbers, it can contain small and capital letters, and so on. So basically a password is counted as a string because we are getting that whole string and we are comparing that. So let's just get into action. We have a main function here, and from where the program basically starts, and now we have two variables for password and for buffer. So in password we are just copying the word ASD, so our password now becomes ASD. So with that row we are copying the ASD into the password. Of course we can do just equals and then quotes and then type ASD, but I did it that way. It really does not matter. I always think it's working better when you're using string functions used in that library right here. So the next thing we have is just a printf that tells us to enter password, you see here. And now we have a scanf. It can be fgets, gets, it can be scanfs if you're using Visual Studio and so on. So we just need an input function so we can input something into that buffer. So in that case, I'm using scanf with the %s, which is the identifier for string, and using %s, now the program knows that we're gonna import string into that buffer variable. So we have two variables. We have password, which we hard-coded to be ASD, and therefore we have the buffer variables in where we are inputting our information. So here we are just comparing the two variables. We have one if statements, and we have string compare, buffer, and password, and we have the brackets here. So we're gonna divide that into sections, and the first section is that string compare, buffer, and password. While string compare is just comparing string, as the name suggests. It's again library used in that it's again function, used in that library, and basically what does it do is just taking the string, taking the first one, taking the second one, and compares them. So if this comparison is equals to 0, so basically if the strings are basically equal, so any character of the string equals to any character of the second string, basically this is going to return 0, so that we know the strings are the same. So the string comparison works really easy and stupid and slow, but it's working. So let's say we have two strings. In one case we have ASD, which is the password, and in the other case we have the ASD here as well. So what does the string compares do? The first bit is A, it's A in the two of them. Okay, the second bit is S, as in the both of them, and the second and the third bit is D, which is in the O of them, and then there is the new terminator of the strings, which says that the string is over. So basically it's comparing every single character of the two strings, and if only one of the characters is different, that means that the string is not equal to the other one, that therefore the string is different. The change can be really small, like in one case it can be capital small letter, in another case can be just number or so on. So if the strings are exactly the same, that means all the characters from the one strings are equals to all the characters to the other string. That means the function is returning 0. And so we are going to the second sections, the if statements. So if that one returns 0, that means the strings are equal. So we have login successful, and else if that is not equal to 0, so it's something else. So we have printf login failed. So this is a quite simple program, and it's working really simple. There is no hashing at all, no encrypting algorithm. I just want to show you how the password management is done on the very bottom level. So as I said before, we have a string compare, comparing the two passwords, one which is hard-coded by us, and therefore we have if statements, and if this function returns 0, that means the login is successful, so the passwords are correct and are the same, and else basically login failed, the strings are not correct. So we have two examples right here. We have I'm using Linux, but do not mind, this code is gonna work exactly the same on any machine out there using Linux, Mac, or Windows. So you can copy and paste the code on Windows and experiment on your own, modify the code and see what can happen. So the thing about C is that it's really portable and can work on multiple OS without huge changes. And in that case, there's no need to change anything whatsoever. So basically here we have examples on the Linux machine. So we have running the program with a.out, and now we're gonna prompt it with password, enter password. Here we are here right now, and the scanf is stopping the progress of the function because it's waiting us to input our data. So the program starts to run first row, second row, third row, and so on, and it stops right here because it's waiting us. So we are writing here wrong, and so wrong is going to get memorized in buffer. So basically we are comparing buffer, which is wrong, and we are comparing password, which is ASD, and this of course is not equal to 0 since they are different, so we have prompted out with login failed. Yeah, and now the second time we run that program, a.out, and of course you can GCC of course compile with different names, so you don't have to run with the a.out, but I've just compiled with the default name, so I'm running with a.out, and now I'm typing the password ASD, so now the buffer is ASD, and therefore the value ASD is assigned to the buffer. So now we are comparing ASD, which is the buffer, and ASD, which is our password right here, and of course it is equal to 0 since they are completely equal and completely the same, and so we have login successful. So when we're building apps or enterprise business applications, web applications, mobile applications, so on, this fundamental principle is almost anywhere. Keep in mind that this password right here can be dynamically allocated, can be used to, or drained from some kind of database, can be saved in file, can be hashed into file, can be hashed and saved into a database, and from database your program can be just pulling out the hash, reversing the hash when using the value, then compare the value, or just hash the input from the user, compare the hash, and then throws to a database. So the ways you can implement that are endless, but it all comes down to this principle right here. No matter if you hash or just rainbow table the hash, break the hash, use the value or hash and compare the hashes, you are doing exactly the same thing. But here comes the security and the encryption and basically the transportation of that password, because it's no better if you are going to use plain text like that. So, but besides any kind of encryption, anything comes to that use. Like we have to compare, we have one defined password in any form, it can be hash, it can be anything. and we have a password, we have a user input. So in case of comparing, if the user enters exactly the same thing as the hard-coded one, we let the user in, and if he does not, we reject the user. And of course, we can implement a user system by adding another variable for user, and we can assign, or using arrays or structures or hashes, we can assign password to user, so we have every user with different passwords. So here we need to add another string comparison for users. So if that users has that password and it's comparing the both fields at the same time, we're gonna let the user in, else we're gonna reject the user if one of them was wrong. So we need both of them to be right. So the user equals the hard-coded user, and the password equals the hard-coded password. So let's just move on and explain how Windows deal with that. So we say that we need to have some kind of a password stored in our operational system or our program, in our case operational system. So whenever a user tries to log in, it just compares from somewhere. So when you, for example, install Windows, you got some kind of a prompt for basically set up a password. And if you don't set up a password, you are letting go without a password. But if you do set up a password, the password is located here on that same file, and that password is being hashed. So basically, if you navigate your PC, see Windows System32 config folder, you're gonna see a SAM file right there, and that same file is where the Windows store their passwords. So any users made, because you know, if the Windows system is domain controller, it may have multiple users, and even the regular Windows machine can have multiple users. So all the passwords of all the users are stored here. So basically, when you, for example, choose with what user to log in, you are basically choosing the user, and then you type the password, and the operational system compare the combination of user and passwords with the combination of user and passwords to that same file. And if one of them is wrong, basically if you enter someone else's user password but it's not for you, you are not going to get in. So this is how Windows deal with that. It just stores password in same file. That password can be accessed throughout the registry files as well. And all I do is basically, whenever you set up a password upon installing Windows, or upon creating user, or upon updating your password, is just getting your input. It just hashes the input and saves that hash into that same file. And whenever you want to log in, it's working with files, with hashes, it's comparing hashes, and it's see how it's working. So here, how Windows store passwords there. As I said before, Windows is working with hashes and only hashes. So with that passwords, Windows is getting your password, it hashes the password, it hashes the user input, it compares the hashes. So the comparison is not done using plain text but hashes, and of course if the hash is exactly the same, the Windows basically is gonna let the user in. The cool thing about hashes is that they are quite unique. Like if I pass one smartphone and hash it, talking theoretically, it's gonna bring up some hash, and if I pass different smartphone, it's gonna bring different hash. So only my smartphone is gonna have that hash. It's quite unique, and that's so it's basically easy to compare hashes, to work with hashes, and so on. Yes, they are not that secure because they are so-called rainbow tables when you can break the hash, but they grant mobility and integrity, so they are nice to work with when we're talking about passwords. So thank you everyone for watching. This is how Windows manages passwords, and in the next video we're gonna go about some practical demonstrations for Windows. I'm gonna show you exactly how to access that same file. I'm gonna show you something called Windows Credential Manager, and so on. So I appreciate you guys for watching. I hope it was interesting, and see you in the next video.